Alright, so I think I'm recording. Let's take a look at this problem. We're looking at rational functions where the numerator and denominator are both polynomial functions. You're dividing two polynomial functions. And we focus our attention on the denominator in order to identify any vertical asymptotes or holes that the graph of this function has. So the key here is going to be our factoring skills or using quadratic formula or completing the square most of the time if it's quadratic. Now if it's higher order, we'll have to use the rational zero theorem or some other factoring methods if it's factored by grouping or if there's just simply a greatest common factor among those. So if I factor this, I have x minus 5 times x plus 1, and the domain, I always want to do the domain before I try to reduce my fraction. So from negative infinity, I'm going to throw out negative 1 and positive 5. Negative 1 is less than positive 5. So when I throw things out of the domain for a rational function, it's going to appear in the graph as either a hole or a vertical asymptote. So since we don't have any common factors, both of these are vertical asymptotes. So this graph has two vertical asymptotes. We can confirm that in just a minute through its graph. But we have two vertical asymptotes. We have the line x equals negative 1 and the line, they're vertical lines, and the line x equals 5. There are no holes in the graph. Alright, so if we go to here, let's turn off all of these previous graphs. So okay, what was that denominator? X squared, was it minus 4x minus 5? Let's go check because I don't remember. Minus 4x minus 5, that was lucky. Alright, so we look at the graph now, we see that we do have vertical asymptotes at x equals negative 1 and at x equals 5, and we can come in and hit this cogwheel to change our colors and make it a dashed line. So we can see, I guess I don't necessarily have to paste it onto the other software. We can see that we have a vertical line here at x equals negative 1 and here at x equals positive 5. Now the graphs, the graphing program does not show enough detail to recognize any holes. The only way that we would have to do that manually is to look and see algebraically if there was any common factors that canceled, or if if we convert this to a table. And see, sometimes I like to keep the equation, so I'll duplicate it and then convert the duplicate to, and if it gives me an extra, I just delete the extra one. Now why, you know what, it's probably because I named something else f up here. Let's see if it might remember. Yeah, it did. So we can see, oh, okay, I thought that said undefined there. If it's 5, so at negative 1 and positive 5 it was undefined because those were our vertical asymptotes, and we just have to say algebraically that we knew that there was no holes in the graph. So I hope that helped, and I will talk to you later.